Okay, so time series is a unique type of problem in machine learning where the time component plays a critical role in model predictions. So, as observations are dependent on adjacent observation, this violates the assumption that observations are independent to each other, followed by most conventional machine learning models. So, common use cases of time series analysis are forecasting future numerical values, example, uh, stock pricing, revenue, temperature, which falls under the category of regression models. However, time series model can also be applied in classification problems. For instance, pattern recognition in brain wave monitoring or failure identification in the production process are common application of time series uh, classifiers. So in this video, we will be like describing the time series data, and in the next video we will cover about the time series model like ARMA, ARIMA, SARIMA for regression problems. Firstly, we can describe the time series data through a line chart visualization. There are many tools like we in this session we will be using SNS, so via line plot. As shown in this image, the time series data depicts an upward trend with some repetitive patterns. To explain the characteristics of time series data better, we can break these things into three components. First is trend, second is seasonality, and third is residual. So trend is basically a long-term upward or downward change in the average value, and seasonality is just a periodic change. And residuals, the remaining part of the time series data, like that is you can say noise. So you can maybe add these three things and multiply these three things to get the original time series data. Okay, so there is another component that we need to study before moving to models. So that is stationarity. So time series data can be classified into stationary and non-stationary. So stationary is an important property as some models relies on the assumption that data is stationary. However, time series data often possesses the non-stationary property. Therefore, we need to understand how to identify non-stationary time series and how to transform it. So basically now we can define stationary data as not depending on the time component. That means like data is not depending on the previous components, like along moving with the time. So that is that. Or maybe you can say there is no periodicity or seasonality component. So there are two techniques mostly used in identifying the stationarity of time series, that is augmented Dickey-Fuller test, and the second one is autocorrelation function. So the ADF or augmented Dickey-Fuller test examines stationary based on the hypothesis testing, where the null hypothesis said that the data is non-stationary and alternative is like data is stationary. If the p-value is greater than zero point zero 0.05, uh, it provides the evidence to not to reject the data is non-stationary. If it is less than, then we can say we can reject the data, or the null hypothesis that data is non-stationary. Secondly, the autocorrelation function. It says it summarizes the two-way correlation between the current observation against the past observation. For example, when the lag is 1, ACF value is roughly you can say around 0.85. That means like the values are correlated by 0.85. And for non-stationary data, ACF drops to zero relatively slowly because no because non-stationary data may still appear highly correlated with previous observation, indicating that time still component plays an important role. So we till now studied like how to detect the stationary or non-stationary data. So let's say if we have non-stationary data, then how we can get the stationary data out of it. So for that there is a technique that most of us use, that is called differencing. So differencing removes trend and seasonality by computing the differences between an observation and its subsequent observation. So differencing can transform some non-stationary data to stationary. So like if you want to remove the trend, we use shift one and take a difference. And here is an example. And if you want to remove the seasonality, then it's just you can try the different lags, that is 12, 24, 36, whichever works for you. You can check, like for this case we it's 12 is working.